Good evening, Professor. This is my personal timetable. As per your suggestion and comments in the last meeting in the RFIC center, so I have planned my priority-based works. So there are three main different tasks that is my priority list in this week. First is to I have modified and I have done all the corrections in the PSA paper, and I already sent to you for your review. Once I will get your reply, then I will submit it in the submission web page. And the second task is the AAO Biosensor research. So from today, we have started the experiment, and we got the results, but we just did not get any positive results. But we are trying to solve the issue, like what we are stuck and what we are, the negative thoughts, negative results, to resolve this as soon as possible. And the third one is also discuss with Prashant and also sit together to write the coronavirus biosensor paper as well. Sir, in the last meeting, we finalized that the AAO substrate is the final substrate to dealing with the detection of coronavirus and the uric acid antibody and antigen. So, as per your suggestions and comments, we have started the experiment and we have already planned the research plan for the AAO biosensor research. So we are basically do the LSPR measurement. So basically the LSPR is the oscillation of electrons in a metallic nanoparticles under the some excitation of the electromagnetic field. And the basic things that we have to know about the LSPR. So when the light emits on the metal nanoparticles, then we it couples the electrons of the metal and to leading with the collective oscillation of electrons, and when the collective oscillation frequency match with the frequency of light, which is due to the electromagnetic field, that phenomena we called as LSPR, localized surface plasmon resonance, and it varies depends on the sensitivity to the refractory index around the particle. And so in our case, we have the MOF, metal organic framework kind of solution, like silver protein complex. So we have the Ag nanoparticles with the egg protein to couple with the silver nanoparticle to make a solution, and we have used as a carrier for this LSPR measurement. So according to the material required, so we have the sample of the MOF sample that is having a 15 millimolar Ag concentration, and the protein concentration is 20 milliliter per liter in a volume. So we have graphene oxide, and the Ag protein MOF complex is basically a metal organic framework complex. We have EDC, NHS, and also we are looking for the another chemical named MUA. It's basically because why we are curious about MUA because normally in the literature survey we found that if the metal organic framework complex kind of anyone they use, so they also simultaneously use this MUA sample as well. So we have tried with our existing chemical like graphene oxide, but today we have started with the graphene oxide. We didn't get any positive results. Maybe it's maybe I think the concentration of the Ag part is a graphene oxide and the Ag particle complex. So we have taken the 2:1, like 2 microliter of Ag protein complex and 1 microliter of graphene oxide, and then we dissolve to mix together and then immobilize on the AO substrate via spin coater. So we found that this one, and so this is my research plan. So it's a AAO Metasurface research plan. It's basically there are two different kind of research plan. The first plan is with using PBS, washing with the PBS solution. So we have two different kind of AO surface. The first is 70 nanometer pore surface area, and the second one is 95 nanometer pore surface area. So today we use 95 nanometer surface area, and then we check the LSPR, and it's a measurement 1. M denotes measurement, and then we immobilize Ag protein complex mixed with the graphene oxide solution and drop like simply we just simply drop cast and then spin coater using a spin coater to uniformly deposition on the surface. Then we again measure the LSPR measurement, and then again we have to wash with the PBS, and after washing we have to double check with the LSPR measurement again, so it denotes as M3, and then we have to mobilize EDC NHS, and then again LSPR measurement. Basically it's a step-by-step measurement system, so we have to be monitoring the step-by-step changes, what we got the changes in each step. So that's why I prefer to washing with the PBS. We have to just think about like is there any changes or not. So we have to wash it again with the PBS and then again LSPR measurement, and then immobilization of coronavirus antibody, and then we have to do the LSPR measurement and then again washing with the PBS and then again LSPR measurement, and then we have to mobilize antigen in different concentration. So in this case I plan to use three different kind of antigen concentration, that is 1, 5 and 10. So 1 microgram per ml, 5 microgram per ml and 10 microgram per ml, the three different concentration that we used on the AO metasurface area. So then afterwards we have to do the LSPR measurement and then washing and then do the LSPR measurement is M9, and then afterwards the coronavirus antibody. Why we use here again antibody? So because we have read that there are so many articles shows the unbonded antibody, like we previously here put the antibody and then wash it with the PBS then and again antigen. So if any unbounded antigen is free on the surface, if when we put the antibody is perfectly binding with the unbonded antigen. Then again the LSPR measurement. So the main focus is to check the LSPR measurement to know the um, bonding between the antibody and antigen at certain concentration. And the second plan I have designed. Before to explain the second plan, today we did this experiment. So we found that this blue line shows the Ag plus protein and the graphene oxide mixing solution, and then we checked the LSPR. So we found that nearby 420 wavelength here, and the same as after washing with the PBS. So this result is not showing the good one. Simultaneously, also do the just check the LSPR of only Ag protein complex that is already defined, but we have to double check. Then we found that this red one is we got the LSPR measurement. The Ag protein complex measurement is quite good, better than the complex of Ag protein and the graphene oxide. And then afterwards we washed the Ag protein complex surface, and then we found that the blue shifted of the Ag protein complex. So we found that the graphene is not suitable for this research, for this AO research, because in the chemical specification, like graphene oxide chemical specification, we found that the graphene flake size is 0.3 microns. It means 300 nanometer size. But if we check our AAO pore size is maximum 95 nanometer, that I already explained in the this my research plan. So the graphene flakes is not penetrate into the pore surface, and also acting like a barrier to enter the Ag particle as well. So we have think about that we have to buy the MUA, and it's very um, it's act like a same constituents of the graphene oxide, the free carboxylic ions as same as the graphene oxide, but the size, the flake size, the particle size is very less, very small as compared to the graphene oxide flake size. So we move to the MUA chemical, and Bruce will contact to the Dr. Daniel to buy the MUA solution as early as possible, and then we start the AAO research. Before to get the MUA solution, tomorrow I have to repeat this again in a different kind of solution structure, like to um, centrifuge my graphene oxide flakes to reduce the flake size, and then we have to mix together with the Ag protein complex, and then we have to check the LSPR. So um, I'm sure I will decreasing the flake size, but one more time I have to check with the Ag protein complex mixed together and disperse on the surface to check the LSPR. So tomorrow I will do it, and then uh, I will let you know the upcoming results as well. And the plan second, this plan is quite different with the plan first, because here we didn't wash the surface. We simply just do the AFO nano surface LSPR measurement, and then put the complex structure with on the LSPR measurement, then put the EDC, and then LSPR measurement, and then antibody mobilization, then again LSPR measurement, and then to use the different kind of concentration that I already told you, that the three different kind of concentration is 1 microgram per ml, 5 microgram per ml, and 10 microgram per ml. The three different kind of concentration we use here on the surface. So after immobilization of three different kind of concentration, then we use the LSPR, and then antibody mobilization, then LSPR. But the thing is, I have to we check step by step, and if we didn't get any positive results, so I have to stop this plan and to make a new one as per the literature survey. So why is good MUA surface as compared to the graphene oxide? So basically the graphene oxide solution is having the 300 nanometer size. 300 nanometer. So it's very big, and it's very hard to penetrate the pore surface area. So that's why we move to the MUA. It's a 11 mercaptoindicanoic acid. It's basically very small size particle, and it's very good to make a complex structure with our Ag protein complex to penetrate the pore surface area and to get the positive response. And basically the same kind of antibody we use corona antibody and the uric acid antibody and antigen. So we have already um, asked to the Bruce to order this chemical as soon as possible, and then we have to, once we get this chemical, to we start with the our antibody and antigen. So here I am giving you the example, like the comparison between the graphene oxide and MUA, because of the particle size, because of the large particle size of the graphene oxide, it's impossible thing to do the detection method. That's why we move to the MUA. And the future plan is to also to check the SCM for better characterization, to check our complex, how it works and how it can be combined with our specific substances. And also tomorrow we have to be check on the making the different kind of composition with the graphene oxide and the Ag protein complex to know the problems and to resolve this issue as soon as possible. And this is the basic information of the MUA instead of graphene oxide for antibody mobilization on Ag. This is the link, product link, that we have to buy this, and we move to the 98 gram 98% product, because there are so many papers they use 98%. So in this current status of my PSA biosensor paper is already in minor review. So the revised PSA manuscript correction is already done and I already sent to you, and the deadline for the submission is the 14th of October 2020. So once I will get any response from your side, then go for the submission via online submission system. And thank you, sir.